Speak now or forever hold your peace. We are recording you. So if you don't want to be recorded or something like that, then you'll have to jump out of the meeting. So welcome everybody to Thursday night. Tonight we have Jes Schultz, and she is going to talk with us about Azure SQL database, which Azure SQL database options should you choose. Now, for those of you who do not know, I'm going to go through her bio here really quick so I don't say anything I shouldn't. Jes Schultz is a software engineer with Microsoft, and she's got an experience with a wide range of SQL Server features, all the way from SQL 2005 through 2019, and is on the cutting edge with Azure technologies. So she's joined us a number of times. I'm not going to go through her whole bio because you guys can read it, but she is awesome with this stuff. We're so happy to have her. Jes is a dear friend of mine. It's always good to have her speak at our local user group. So with that, I will hand it over to Jes.
All right. Thank you, Jared, and thank you for having me. Thank you to everyone who is taking time out of their evening to join us. I know that after a day of most likely working from home and staring at your computer screen, that sitting at home and staring at your computer screen might be a little bit repetitive, but I appreciate it. And I am indeed here tonight to talk about Azure SQL, different deployment options, etc. Thank you for the introduction, Jared. As he mentioned, I'm a software engineer at Microsoft. I work in this organization called Commercial Software Engineering. We're a small org that works hands-on with customers to do code with engagements in Azure. So I work in Azure 100% of the time for the last year, and I've come to realize that there's a lot of challenges around adopting different database platforms, including our Microsoft SQL Server and SQL database. And one of those is just the sheer number of choices, right? I've been working with Azure SQL since it was version 11 back in the day, and you couldn't add non-clustered indexes, and it was really limited. It's grown up significantly in the 10 years it has existed. That blew my mind earlier this year when I found a blog post from maybe February of 2010 announcing the availability of Azure SQL. So it's been around 10 years now. A lot more companies are starting to use it, but it's also gotten a lot more complex to try to figure out where to start. So to lay the foundation, especially for anyone that's not been exposed to it to any great depth yet, let's talk about just the basics of Azure SQL. So it's not just a SQL server in the cloud. So the Azure SQL family of technologies is our platform as a service, or PaaS offering, meaning that it's fully managed. The point of Azure SQL is to take away the management portion, take away the maintenance portion, and focus on developing new features, completing your application, making it run faster. Some of those management functions that are handled are, any hardware upgrades, any operating system upgrades, any SQL Server upgrades, taking backups, running monitoring in the background. You don't need to do any of that work. It is all done by the service. That patching means that Azure SQL is always running the latest stable version of the database engine. One of the benefits of developing Azure SQL databases for cloud native applications is that for SQL Server and SQL database, the engineering teams have what they call a cloud-first development option. Features now get delivered to Azure SQL before they get put in SQL Server. And this has been a trend for many years now. Think about Query Store, introduced in SQL Server 2016, but it was running in Azure SQL for well over a year before that. A lot of our intelligent query processing features, the IQP, and then the adaptive query processing features, AQP, that have been introduced in 2017 and 2019, existed in Azure SQL long before they were in SQL Server. So again, Azure SQL is platform as a service. It's cloud-first development. Always giving you the latest and greatest. And with that, we also have our availability guarantees, SLAs, and we guarantee 4 nines of availability. And HADR, another complex topic. I could talk about that for a couple hours if you want to have me back in a few months to give another presentation, but do know that we do guarantee availability. So why would you want to choose Azure SQL? A lot of the things that I just mentioned: cloud first development, automatic backups, automatic high availability, easy to use disaster recovery, scaling. One of the biggest benefits of having your database in a cloud system is that if an application becomes hugely popular, your volume of data grows, your number of transactions grow, it is easy to request more resources and scale up to that. Or if you have an application that's used, like I've worked with retail customers, databases are really busy October, November, December, maybe January while returns are happening. The rest of the year, much less activity. Scale down in less busy times, increase your resources in the busier times. And you can do this without having to have these huge migrations of, hey, I need this other server with all this hardware. Let's fail over. Let's plan a fail back. Just scaling up and down in a cloud service is a lot easier. But the downside of going into the cloud is that it's not just submitting an infrastructure request anymore to say, I need a virtual machine with 4 CPUs and 16 gig of memory and needs to be attached to this SAN and have 500 gig of space. Instead, when you go to start an Azure SQL database, you're going to be faced with things like, how are you going to structure the server? So what's your deployment method? What kind of purchasing model are you using to pay for the service? Within that purchasing model, how much compute? What type of storage? And then within that even, you can choose a provisioned or serverless compute model. In the end, there's so many choices, it looks something like this. I came up with this graphic a couple months ago as I was trying to explain to a customer that you could only do serverless under a vCore model of a single database, but not managed instances. And they were very quickly overwhelmed by that. So when I say that you have all of these options about your server, it's this, right? So our deployment model is this first level. Managed instances versus single databases versus elastic pools. Within that, we have how we pay for it, right? The vCore versus the DTU models. Underneath that, we have our different service tiers. And you'll see that in DTU, we have these basic, standard, and premium features. And under vCore, we have general purpose or business critical or hyperscale. And then there's that compute tier, right? Provisioned or serverless. What do all of these things mean? Which one do you choose for your application? That's what I'm going to talk about tonight and try to help you decide, like this flow chart at the top, what do I start with and how do I work down that little list. The first choice that you'll want to make is how are you deploying the SQL Server and its databases underneath. And right now we have 3 primary choices. Managed instance is going to give you a server level management capabilities, much like an actual SQL Server instance in a virtual machine or a container. Single databases and elastic pools really pull away from a server level deployment and focus more on database level deployment. So when you deploy a managed instance, you're going to be deploying a whole collection of system and user databases with a shared set of resources. It's this blend between an infrastructure as a service, again, full SQL Server instance with multiple databases attached that can all talk to each other. But again, all of the stuff that's underneath it, the OS, the SQL Server version, the patching, the HA, that's all abstracted away from you. Managed instances offer near 100% compatibility with on-prem SQL Server. Right now, there's only a handful of features that are not supported. Off the top of my head, the only one I can really think of is like file stream isn't supported and you can't directly attach an MDF. There's a couple other little syntax things. But other than that, a managed instance is equal to a SQL Server instance. What this means is that it is a great model for lift and shift. Really works well for moving existing on-prem SQL Server or SQL Server in a virtual machine into a PaaS offering. Minimal code changes, not having to worry about having features turned on that aren't supported. So again, the primary use case for managed instances, moving existing on-prem SQL Server instances, particularly those that have related databases that might need a lot of cross-database queries, or those that rely heavily on some sort of server level feature like resource governor, service broker, that sort of thing, that are not offered in the single database model. All right, so comparing that then with single databases. When you deploy an Azure SQL database, and it's just a single database, that's it. You're saying, I would like this database named AdventureWorks. It is going to be attached to a logical SQL server. This database is going to have the equivalent of 2 CPU cores and 10 gig of RAM. All of the resources go directly to that database and the transactions processed in that database. The single database model is really great for new development when you can work within the constraints that are given to it, because a single database is not 100% equivalent to what you might be used to with SQL Server on-prem. There are more limitations. There are a lot of features that aren't supported. So some of the primary use cases for single databases. Again, brand new development. Databases, primarily if the developers are building a cloud application or something that strings together various technologies like Azure Functions, Stream Analytics, It could be a great data sync for, moving and transforming with Azure Data Factory. It also can be used as a migration destination for simple databases. Think about a single on-prem SQL Server database, or a MySQL, or a Postgres database. Anything that just has simple relational data that needs to be ported into a simple relational database. One of the big things to note about single database, and there's more information if you go, I'll show you where to download my slides from. There's more information in the notes on these slides. There's a lot of features that are available in SQL Server and managed instances that are not available for single databases. And they're really important things to know before you get started, especially for something that has existing infrastructure. Some of the biggest blockers that I see. Number one, there's no cross-database querying unless you set up external tables, external data sources, and run queries like that. So you can't just natively say select, star from database.schema.table in a different database in SQL database. There's no concept of SQL Server agent in single databases. If you rely heavily on that on SQL Server agent to run jobs, particularly not just backups and check DBs, the things that are handled via the platform as a service, but if you have nightly ETL loads, things that kick off stored procedures to move or transform data, partitioning, you would have to recreate that using other Azure tools like Azure Automation Runbooks. That can be a big blocker for some applications and databases. There's also things like no CLR, no file stream, no service broker. So again, single database is really designed to be a landing zone for relational database where you want to focus on the performance of it and not worry about the management of it. All right. Then that third deployment option is the elastic pool. So elastic pool is a collection of single databases. Same rules are going to apply around feature set. And again, backups are managed the same way. High availability is managed the same way. The difference comes in two primary ways. When you create an elastic pool, you say, okay, I want this elastic pool to be assigned 8 vCores and 40 gig of RAM. And you can have 5 databases that share that, or you could have 105 databases that share that set of resources. It depends on what kind of usage patterns you have, how many resources you might need overall. Elastic pools were really designed for that multi-tenant database pattern where it might be used commonly with software as a service type applications. That would be something where you have many databases. They all have the same schema, but each database holds different customer information or different tenant information, different portfolio information. And on top of that, the elastic pools allow you to say, I can group these 100 databases together because, overall they have very different usage patterns. Some are only busy for 2 hours in a week. Others are only busy for 2 hours in a month. It doesn't pay to have all of the resources given to it all of the time. The other feature that can make Elastic Pool inviting for some people is that there's this set of tools called the Elastic tools. Elastic tools allow you to run cross-database queries or run a T-SQL script against a set of databases at a time, kind of like SQL Server Agent. The drawback to the Elastic tools is that that feature has been in preview for 2 years, 3 years. No commitment on when it will be generally available. So you have to have some risk tolerance for a feature being in preview, maybe not fully developed, maybe not fully supported. So again, to recap, those are the 3 deployment options: managed instances, single databases, Elastic pools. I'm going to pop here into chat. Do we have any questions in the meantime? Okay, if you do have any questions at any time, please feel free to put them in chat. I will come back and check at the end of each session or section. Okay. So say you've settled on your deployment option. Now let's talk about, after you've chosen how you're going to straighten out those resources, how are you going to pay for them? We have 2 primary purchasing models. The first one is DTUs, or database throughput units. This was the original purchasing model, so it's been around as long as Azure SQL has been around. It, rather than saying I want a set amount of cores, I want memory, I want this much storage, and being able to scale them all independently, what you got was a set of resources. And if your workload was CPU intensive, you might need to add more DTUs. If your workload was IO intensive, but very small, you still might need to add more DTUs. People found it hard to use. It was really confusing. It was, especially in terms of migrations. Okay, so I'm taking this database that's on, that's one database out of 20 on a server that has 16 CPUs and 64 gig of RAM. How much resources should I give it? Don't know. Kind of hard to isolate what are the resource uses of just this one database. We have a tool called the DTU calculator that can try to help with that. But overall, people were very frustrated with that, made migrations hard, made pricing hard. The other downside to the DTU model is that every tier comes with a default amount of storage allocated and then a set maximum amount of storage. And you can't scale those 2 things separately. So say that I have a 2 terabyte database, that's just a lot of archive data, but it's not very busy. I would still have to pay for one of the premium tiers in the DTU model because lower tiers only support up to 1 terabyte. So DTU, initial model, had some flaws, wasn't incredibly popular. A couple of years ago, we came out with the vCore pricing model. In this one, you're going to choose what compute resources you want. And then separately, you choose what type of storage and how much storage. And you can scale your compute up and down. You can scale your storage up and down. The 2 are now independent. One thing to note about the vCore model, if you've ever created something like a virtual machine in Azure, you know that we have set virtual machines where you get 2 core and 7 gig of RAM, or you get 16 core and 84 gig of RAM. It's like that in vCore as well. The amount of cores and memory are tied to each other. All right. So the service tiers that are, so within the purchasing model, then we have the different tiers of service that are available. So within DTU, you can choose basic, standard, or premium. Within vCore, you can choose general purpose or business critical, and currently for single databases, you can choose hyperscale. The difference here in the DTU model, basic is meant for just really small, development style things. You can only have up to a 2 gig database. You get 5 throughput units, which is tiny. Standard goes up to 3,000 DTUs and a 1 terabyte database. Premium can get up to 4,000 with a 4 terabyte database. Now, in the vCore model, you have more options. So I mentioned when you go with the vCore model, which you can do for managed instances, single databases, and elastic pools, you choose your compute stack, and then you choose your storage stack. So the compute options we have available, there's 3. Gen 5 is, for every core you get 5.2 gig of RAM. So it goes from 2 cores with 10 gig of memory to 80 with almost 400. We recently went general availability with 2 other options. One is a CPU optimized family of choices. You'll see that the memory is significantly lower. 72 cores only yields 136. But newer generation of CPUs, much better caching, much lower latency. On the other hand, if you have a need for more memory, maybe to support more analytical style workloads, the M series is memory optimized. You'll see it goes up to almost 4 terabytes of memory on those. Now, after you've chosen your, so the other thing that you need to choose with vCore is what type of storage do I want? The storage is going to determine, to some extent, your RPO and RTO for your recovery. It's also going to affect your IOPS and your IO latency, because general purpose is for not business critical, smaller databases with lower latency requirements, because it is premium blob storage. That means that the compute resources exist over here, the storage exists over here, and it does have to, make a trip across the wire to get there. With general purpose, you can choose either the Gen 5 or the CPU optimized hardware. If you have an application that needs lower latency or more IOPS, go with business critical. In this model, the compute and the storage sit on the same underlying hardware together. So it's local SSD storage for either the Gen 5 or the M series. So that's faster. And then another topic that I could talk about for at least an hour is our newest model, the hyperscale database. The hyperscale database is not just faster than local SSD storage. The hyperscale product is a complete re-architecture of the underlying storage system. Hyperscale has broken this, in a traditional SQL Server environment, right? We have one box that holds our CPU, holds our memory, holds the SQL engine, holds the, cache, right? So our buffer pool of pages that's being read, holds our transaction log. All of that's on one service and very interconnected, very interdependent. Hyperscale has broken SQL Server into more of a distributed style system. There's a head node that has a small cache, Underneath that are a bunch of page servers that can hold up to, I think it's like 128 gig of cache independently. Those are SSD. Then underneath all of that, for the databases, which can be up to 100 terabytes in size, significantly larger than any of our other SQL offerings. That's hosted on just Azure Blob Storage. And then we have this fourth component called the log service, which manages the writes to and reads, the writes to all of these different pieces. Hyperscale is amazing. It definitely solves a couple of long-standing problems. Very large databases with long-running transactions, databases that need to, like when they fail over, they need to be up nearly instantaneously and not dependent on, again, long-running transactions. So hyperscale is cool, can be expensive, but I've used it in a couple of projects. If you have any questions about that or interested in learning more, again, there are some links in my slide deck, and feel free to send me an email or a message on Twitter and I can talk to you more about that. So there we go. Do we have any? So we've talked about DTU versus vCore, and then within the DTU model, you have your 3 tiers. Within vCore, you have to make a few more choices. I feel like it's gotten more complex, but it's also better because it used to be like you just had Gen 5 and then general purpose or business critical. I like the fact that we now have CPU optimized and memory optimized hardware available for you.
No questions in chat. You're good.
Okay, excellent. Thanks. So then last but not, sometimes a question would be nice so I can take a drink of water. So y'all just have to bear with me for a moment. All right. So then the one last thing is the compute. And what we call the compute tier. We're starting to roll out a new set of services in which we have provisioned compute and serverless, or if I was in marketing and got to choose the name for it, I would call it on demand. In general, I hate the term serverless. What's the difference? So these two options right now, if you go back to this offerings slide, right? So we've talked now about the managed instances, the single databases, and the elastic pools. DTUs are only available for single and elastic pools. Managed instance, single database, and elastic pool all have vCore. You know, anything with vCore can have general purpose or business critical. It's this path right here. I just pointed at my screen. You can't see me pointing at my screen, so let me grab my little laser pointer. So it's this path here where you go, I want a single database. I'm going to use the vCore model. And its first iteration was only available with general purpose. Hopefully, new offerings roll out soon. You have this model of provisioned compute or on-demand serverless compute. What does that mean? All right. When you choose a provisioned compute model, you're saying, I want this database to have compute, memory, and storage available 24/7, 365. It could be used at any point in time. You know, business users are connecting to it all the time. Applications are connecting to it all the time. It constantly needs to be receiving data. Even if that usage varies up and down, you just always, you'll always need it. In this case, it's billed at an hourly increment. This new option, serverless or on demand, is really designed for databases that are used for a period of time, and then no connections are open to them. there's not a constant stream of data going into it. There's not a constant set of users connecting to it. In this case, if you have something that's used only rarely, you could put it on the serverless model. The way that you configure this, when you go to set it up, you say, okay, I want this database to use between 1 vCore and 8 vCore. And if it is inactive, if there are no user connections made to this database in a 6-hour period, I want you to just take it off the compute completely, just keep the database in storage. And then if no connections are made to the database for 12 days, for those 12 days, you're only paying for the storage. There's no incurred compute costs. The next time an application makes a connection to the database, it wakes it up from storage, puts it on, or enables the compute resources that you've specified, and quickly warms up some cache and starts working again. And it will do that again until there's been no user connections for that 6-hour time period you specified. It backs it off, gets rid of the compute, puts it in storage. You're only paying for the storage. So serverless is a lot more dynamic. It's a little bit more closer to that auto scaling model. We've recently made some updates to how big those windows can be, where it's considered inactive. And in this case, you pay for compute per second rather than per hour, or for every hour it's up and running. Use case for this that I've seen, there's actually a couple. And so again, I've used this with a couple of customers. It's common to use this again in kind of the single tenant or multi-tenant databases where that software as a service type, where you have lots of little databases. Maybe the databases hold one customer worth of information, or in the legal profession, like one case worth of data, or in insurance, one portfolio of data. You're not always writing information into an insurance portfolio, right? Might do it when you create the case, or you create your portfolio. Probably don't need it on a daily basis, but every so often a payment gets applied. Maybe your analysts once every couple of months want to run some information about claims. In that case, could be very useful to have these small databases, parked in storage, and you only spin up the compute when you need it. I've also worked with some customers that will hold databases on the serverless model. And if they get like X number of requests, then they go and they move them over into an elastic pool so they can be around for a longer duration of time, have more compute power available to them. And then after X amount of time of non-use are moved back to the serverless model. So I've seen some kind of cool things with moving things around between all of these. So that's the talk through all of those different offerings. Again, you have your deployment model, managed, single database, or elastic pool. You have your pricing model. Do you choose vCore or DTU? Within that, the service level, DTUs have the basic, the standard, the premium. vCore has general purpose, business critical, and for single databases, hyperscale. And then we're also starting to try this new provisioned and serverless model. Before I show a couple demos of creation scripts to show you how to make some of this stuff, are there any questions in chat?
We do have one. So I'll let you drink your water and then.
All right.
The question is, how does security work specifically for encrypted connections? We use company-generated certs right now. So how would encrypted connections work in the cloud? And if I understand the question correct, he may be asking, can we bring our own certificate for those encrypted connections, or do we have to use self-signed certs on the server?
Okay. Great question. Security is not my number one thing, so I might not know all of the terms exactly. I don't want to say security is not my number one thing. All of the terms for the security that we use in Azure are not necessarily the ones I'm the most familiar with, but we can enable up to TLS 1.2, I believe, for encrypting the connections. For actually using certificates, you can, for all of these offerings, bring your own keys and bring your own certificates. For some of those features, you do need to use like Azure Key Vault or like some sort of other key store to host them, because you're not going to have like an underlying Windows server path where you can specify the keys. So you need to use a key vault or some other sort of customer managed key option. But that can be done. And I would say 90% of the customers I work with just use the default of Azure Key Vault to store all of that. The tools to use Key Vault, whether you're using PowerShell, accessing it with CLI, accessing it with the REST APIs, accessing it with T-SQL, all of those are fairly mature and well developed and work well. Any other questions in there?
That is all I see.
Okay.
Steve, did that answer your question?
Yes, it did. Thank you very much.
Okay, excellent. Yep. If you're looking, if you have any more specific questions about that, look up customer managed keys in Azure SQL. Look up Azure SQL plus Key Vault. Those are going to be the terms that you'll want to search for to get more information. So when it comes to creating these resources, I'm going to give you a quick tour of doing it via the portal. If you have not seen that before or haven't seen it in a while, the experience might be new. But then I'm going to show you the way that I do 100% of my creation, which is PowerShell. So for those of you that may not do a lot of Azure work, maybe I will tell you that the single biggest thing that you can do to make Azure work and administration better, faster, easier is learn and love PowerShell or CLI, some sort of scripting language, because it's just like when you get started in SQL Server. You might start with SQL Server Management Studio, right click on the server name and create your database, or right click and do your restore, right click and do a backup. I did all of those things when I first started as a DBA many years ago, my junior DBA days, and eventually realized that being able to script things out and the next time I needed to do something, just pull up a script, maybe change a couple of parameters and execute it real fast was a lot easier than clicking through screen after screen after screen. You will feel exactly the same way about the portal. Plus, on the portal, stuff changes constantly. I will go to do a demo. If I gave this presentation 2 weeks ago for another user group, and I can almost guarantee something will be in a different place or there will be a new option I've never seen before. So PowerShell will be one of your best friends in Azure. So for creating new SQL SQL servers, you can either go to create a resource, or we have this new blade that is called Azure SQL that just kind of groups all of your Azure resources, all of your SQL resources, whether they are the managed instances, whether they are the logical SQL servers, whether they are the individual databases here in one pane. So if I want to add a new Azure SQL resource, I click add and it'll ask me, do I want a SQL database? Do I want a managed instance? Or The part I didn't even talk about was virtual machines. So let's talk about just a SQL database. Do I want to start with a new logical server? Do I want to do a single database? Do I want to do an elastic pool? I'm going to start by specifying the new logical server. This is something where you choose your subscription. We'll choose a resource group. Then I choose my server name, which its fully qualified name is going to be database.windows.net. So I'll say Jes/Chicago, what location I want it to be in. And every time you create a logical SQL server or a managed instance server, you do need to create an admin account. This is roughly the equivalent of the SA permission in a SQL Server instance. It is the basic account that then allows you to generate other accounts with lesser permissions. Right now, it has to be a SQL authentication account. And after I've created a SQL auth, then I can go in and create an Azure Active Directory authentication account, which I can use. But right now, there's no way to get around the fact that you have to have this particular, and it makes you put in a long, ridiculous password. And mine don't match because I can't talk and type something like this at the same time. There we go. So one of the things that you can do when you're creating these SQL servers is say, allow other Azure services and resources to access this server. If I say no, and I try to do something like create an Azure Data Factory pipeline that dumps data into this database, it's going to fail. If it's something where I'm going to have an application that I just want to set up specific firewall and port rules for, I can say no. So just be aware that that's bit me a couple times. Advanced data security, things like vulnerability assessments can be enabled. You can tag your resources. All right. And what I'm doing now is just creating a logical SQL server, which I can access using I don't have, so let me, okay, give me my taskbar, please. I'm going to show you the Azure Data Studio tool for connecting to and querying servers because it's an Azure presentation. Again, if you've doesn't fully replace SQL Server Management Studio, doesn't quite have all of the source control features that Visual Studio SQL Server Data Tools does, somewhere in the middle. When I want to make a new connection, I put in database Windows Net. I feel like that was not the right one. Remember my password. And if my resources have deployed successfully, which they have, it will let me connect. You'll see it gives me a firewall rule error. By default, your SQL servers controlled list of IP ranges. So here we go. I've connected to my new server. You'll notice the only database I have access to is master. To create a database on that, what I can do then, go to my resource, create database or elastic pool, but notice all of these things that I have to go through. I have to enter a database name. I can choose pools here. I can choose, this is where all of those different pricing options come in, right? So I can choose the DTU model, basic, standard, premium, or I can choose vCore with the general purpose, the business critical, or the hyperscale. I'm just going to leave the defaults for now. Go through networking. It's going to pick up a lot of these settings from the server that I created. I create a sample database. Have to do all of that. Meanwhile, let me show you. If you go to my GitHub repo, which is github.com/girlgeek/Azure SQL Server. I have, first off, you'll find the slides here under choose the right Azure SQL deployment model, and you're also going to find a bunch of PowerShell scripts that will help you use a lot of these resources. Let me post that link, and let me give you an example of what that looks like. So I'm going to choose new-AZ SQL database and zoom in just a touch because I know that's hard to see. And this is how we do it with PowerShell. We connect to our account. And I do have a hard stop in the next couple of minutes, so I'm going to get through this as much as possible. Oh. The authentication, when you have multiple subscriptions, multiple tenants, and multiple two-factor authentications, is just it's an ordeal sometimes. Okay, so I have my I've connected, and this is what that same process looks like in PowerShell. We select a specific subscription to assign our resources to. We select a specific resource group that we want to deploy to. We use the get-az SQL server to choose a logical SQL server. This isn't displaying well with my Zoom. Enter. Okay. And if you need to, you can create a new logical server using new-AZ SQL server. Notice how much less confusing that is than having to click through 4 different screens. There's even a command, get-az SQL server firewall rule and new-az SQL server firewall rule, where you can pass in a starting IP address and an ending IP address to either allow a specific IP or a range of IP addresses through. So we can set that right there. And then what you do is you specify your database name. Oh, yep, last time I did this, it was for the Northeast Ohio SQL Server user group just a couple weeks ago. You set your database name. You set either your DTU options of edition and tier, or your vCore options of your not storage edition, your vCore model, and your generation of hardware. And then you simply issue a New -AZ SQL database command, passing in your specific resource group, the SQL server you want it attached to, that database name, and then the compute resources that you chose. And I think I forgot to set something, server name. Yeah. And that is the equivalent of doing it in PowerShell. If you want, feel free to go to my GitHub repo, clone it, download it, or even just look. I have some other options here showing you how to do things like create a new elastic pool, create a hyperscale instance as well. So that was my quick run through of all of the different options. Again, definitely go to my GitHub repo to get my slides and scripts. And if you have any other questions, here's my contact info.
Thank you so much, Jess.
Yeah.
Thanks, Jess.
I hope that was helpful. I do see one question about how do you handle daily jobs on Azure SQL database? Common question because there is no SQL Server agent. Most of the time I've set up Azure automation to run PowerShell scripts that kick off either PowerShell or T-SQL. And there's some examples of that out there in my GitHub repo, I believe, as well. All right, cool. I hope you guys got this. I'm just going to post this stuff in chat. Again, I do have a hard stop. I need to run out to an appointment, but I hope this was helpful. And if you have any other questions, feel free to reach out.
Awesome. Thanks again, Jess.
Yeah, thanks, Jess.
Go get your appointment. Thank you so much. We'll send any questions your way if we have.
All right. Again, thank you everyone for taking some time out of your evening, and I hope to see you in person at an event maybe sometime next year.
Thank you.
Okay.
All right.
Thank you.
Have a great evening.
You too.
You too.
So for everybody else that's sticking around, I was doing kind of some research for Steve Clark there on that question about the TLS cert, because usually you can bring your own key. As far as I can see, there is no way right now to bring your own cert for TLS. That said, Azure SQL Database, Azure Managed Instance, all that stuff absolutely uses TLS. In fact, it forces it. There is no way you can connect to an Azure SQL database without using encryption. Now, the way that it works is the client goes and actually says, hey, I'm trying to connect to you. And it says, but you have to be encrypted. So there's a little back and forth, which could actually create what's called a man-in-the-middle attack. So I'm going to send my information to Azure first, and it's not going to accept it. But in sending it, I may have opened up a spot that was unencrypted for an attack to come in and grab that information and start jumping. So it is recommended to have encrypt equals true in any of your connection strings, and to trust the server certificate equal to false. And I just put that in a link in there. But as far as I can tell, we can't change that. It is a back-end Azure Microsoft signed certificate. I can't find a place to change it yet, but at least this article talks about TLS and how it's used, and maybe that can lead you somewhere. But as of this point in time, I can't even find a place to update that.
Okay, because in articles on TLS, it says that when you use your own cert, it's higher security than when you use the SQL Server self-signed cert. So just curious.
And that's true. And in fact, we are telling you to trust server certificate equal to false. So when we have on the connection string the trust server certificate, that is a self-signed certificate that would be in a typical on-prem installation of SQL Server. In the case of Azure SQL Database, it is not a self-signed cert from the quote server, because it's not actually a server that you're using, right? It's this abstraction of platform as a service. The certificate that it's using is actually a fully certificate authority signed certificate for your Azure SQL database.
Oh, wow.
Okay?
Oh, wow.
It's just not something that you are going to be able to use or to change. And as far as I know, here's another article I found that shows you how you can actually verify the certificate location through DigiCert.
Oh, that's interesting, because right now our cert generating authority only grants, it's getting to be the standard that people don't generate certs that are good for more than a year. So that means that it would be a lot of work to go in and yearly change all of them. But
right.
Assuming that Azure does that for you, that would be marvelous.
Yeah, and I mean, in the world of security, we can't assume that, of course. But I'm sure if you dig around using the Microsoft documentation that I sent there and some other stuff, it's probably out there. We also have, I think, if you go to like aka.ms/security center or something like that, it should allow you to dig down.
What was that? AKA security?
I'm gonna, let me see, aka.ms/security center. No, that's an actual service that we have. So I don't have the link, but if I remember, we can email it out to the group in the next email.
Wow, thank you very much.
Yeah, no problem. Or you can email me directly too if you want, Steve, at jared.carney@microsoft.com.
Okay.
Cool. Great. So that hit up on all the questions in there. I think, and let me see, Saif, did you get your question answered? Are you still there? Okay. He was asking how to automate anything in SQL Server without an agent. And there's a couple of ways. There's Elastic Jobs, and another way to do it is through it's an automation account within Azure where you can run PowerShell scripts against different targets. So there's a couple of different ways, and it really just depends on your skill set and what type of features they may or may not have for the particular schedule that you want. Cool. All right, everybody. Well, Ross, do you have anything else to close out with, or?
Yeah. Next month on September 10th, that's our next meeting. We're going to be having David Keeshan present data management using Azure.
Awesome. So yeah, everybody.
Yeah, kind of dovetail onto this session.
Yeah, exactly. And David is a Chicago SQL Server user group attendee, so he's local, and so I think that'll be cool. I think he's local, pretty sure. All right, great. Well, with that, we will stop the recording. Thanks, everybody, for attending tonight. And as soon as we figure out what the public link is for the recording, we'll make that available. So everybody have a good night. Stay safe. Thanks.
Thanks, you too. Thanks, everybody.